Alright, 14.58 says that we have an ornament that's shaped as a hollow sphere. We're all familiar with how those look, and it's hanging off of a branch of a tree. So, let's go ahead. Here's the branches of our trees here. Here's our fancy little ornament. Alright, so there's our hollow sphere. It has a mass of 0.015 kilograms. 0.015 kilograms. And it has a radius 0.05 meters. And if we pivot this, just pull it back and let it go, it'll act as a physical pendulum as it swings back and forth along the branch. And the friction between the hook and the branch is negligible for the purposes of this problem, and we're asked to find the period. So for a physical pendulum, the period is given by 2 pi times the square root of the moment of inertia over mass times gravity times length. So now our first problem is to find the moment of inertia, which for a hollow sphere is given by 5/3 times the mass times the radius squared. So we can go ahead and find that right away. Our mass is 0.015 times 0.05 squared, which comes out to be 6.25 times 10 to the negative 5 kilogram meters squared. So what we're going to do is we're just going to go ahead and plug this into our equation for our period, which is 2 pi square root of 6.25 times 10 to the negative 5 kilogram meter squared. And that's going to be over our mass, which is 0.015, times our gravity, which is 9.8, times our length, which is our radius, 0.05. And that's going to be kilogram, meter, meter squared per second squared. From the units for these other variables here. So that'll cancel out our kilograms and our meters squared. So now we have this in seconds squared, which once we apply the square root here, that'll be in seconds, which is the units we need for our period. So again, we know that we're on the right track. So, we do this math, and we find that our period is 2 pi times the square root of 8.5 times 10 to the negative 3 seconds squared. It's going to be 2 pi times 0.0092 seconds, which is 0.58 seconds is our period. That's the time it takes for our lovely little ornament to swing back and forth.